Welcome to another episode of TrueNAS Tech Talk. On today's episode, Fangtooth is out in beta. Yay! And we get into the nitty gritty of the various types of backup and replication methods that TrueNAS supports. Lots of good stuff there. And we're going to try and distill and tackle some very detailed user questions about special VDEVs, metadata, and a little bit more history on TrueNAS. All that coming right up.
Yeah, we got some good questions here. The very long ones, very detailed. I love this kind of stuff. We'll try to tackle as much as we can on this episode, but we might have to split some of these up again.
Yeah, and when you're sending questions, you'll have to remember if you want us to read it in its entirety on the air, it does have to be condensed down somewhat. As much as I appreciate a page and a half of text, it is a little challenging sometimes in this format to go and get into detail. But we'll do that on the back end of the show. First, let's get to the more pertinent news for this week. So, of course, the biggest thing this week was yesterday. So it's a little less than 24 hours from the time we're recording this. Beta 1 of Fangtooth has dropped. So that's awesome. We're excited. Already seeing people upgrade and kick the tires on it. That's what a beta's for. Please do that. Early impressions, all the kind of basic NAS features appear to be pretty solid. We didn't expect a lot of churn there. The feature that people are, of course, playing with the most now is instances. So let me explain that first, though. What the heck's an instance? So virtualization in the UI has been renamed to instances. We're kind of keeping in lockstep with Ancus's terminology there, which really does kind of make sense because it was this weird, is it really virtualization? You have LXC containers, you have both KVM, VMs. So we like the instances terminology and decided to go ahead and stick with that. And so within the instances UI, you'll have an option to deploy either lightweight containerized instances or KVM backed instances of, full featured virtualization. So it's cool. It's interesting. It'll be a little different. We hope people enjoy that when they start playing with it. Of course, that's where the most of the issues are probably going to be found in the beta, considering this feature is experimental and the fact that it is a beta. So we want that feedback. Please test it. Please find bugs. Please kick the tires and give us feedback. And again, I think we've mentioned this in previous episodes. There's that little smiley face button up top. Hit that button. You can send feedback. You can submit bug tickets. You can do it all right there within the UI. So we want to make this feature and all the other features in this Fangtooth release battle tested and solid. So please do send that feedback. Earlier is better than later. So we have time to address it for RC1, which is only about a month away. So that goes quick. 4 weeks is not a whole lot of time to investigate issues and then write solutions and get it tested and released. So again, if you have feedback in the next week or two, get it in immediately and we'll see if we can get it addressed for the RC.
Absolutely, yeah. Whether it's, as Chris says, if it's a bug fix, if it's a general feedback, if it's a usability thing, if it's like, hey, I wish I could see this kind of stuff on my VMs, submit it in. That smiley face is right there. If you're wanting to submit a debug ticket, you do need to log into a Jira account. But if you're just doing the smiley face with the star rating, if you want to tell us, hey, this is great, again, you don't need to log in for that. Click in there, click the stars, say, hey, you guys are doing a great job. And we appreciate all the little bits of kudos that we get on any kind of social media. Chris, I try to courier those back to the engineering team. It always makes their day when they see somebody saying, hey, you guys did a really great job on this, and we appreciate it. So,
well, we see every submission. Every time you click that, it comes in, we review it. I will say, if you're going to give us 5 stars or no stars, please do put some text commentary in there. You don't have to log in for that either. That's super helpful. Like, I want to know why you thought it was great or why you thought it sucked. Like, I just be frank. Like, we would love this or like that, or this worked great. That feedback is super, super important to making sure we deliver a solid quality product for everyone. So again, keep it coming. And we're really excited to get through this whole beta process and on to release here in the next couple months.
Awesome. Well, hey, we're going to talk about backups a bit today, Chris. So we've got a few different ways of backups protecting your data because, of course, as we all know, RAID is not a backup. So,
you don't say.
I do say. I say it far too often, it seems. So let's talk about the different kinds of ways that we can protect your files in TrueNAS. And of course, this is under the umbrella of trying to get that 3-2-1 backup. Of course, that meaning 3 copies of your files, ideally on 2 different sets of media, with the preference of one of them being an off-site backup. So
absolutely,
let's tuck into some of these.
Well, the interesting thing is TrueNAS has a lot of options for this, and each have their own unique twists and properties because we recognize the fact that there's no one size fits all for everyone. The interesting thing about TrueNAS when you have this many users and this many different use cases is there's a lot of different reasons why, well, I prefer rsync over rclone, or I need to do ZFS replication. So we thought it was worth touching on that a little bit now. And we're going to hop into it by actually starting with how we accomplish backups on the file side first. And really, there's three main R's in that as far as the tools we're using in the background, which you may or may not see on the TrueNAS side. If you're not aware, that's fine. But basically, they're built off of rsync, rclone, and restic. Those would be the three kind of file-based backups that we promote and support within TrueNAS. And each of those have subtle and unique differences. And it's important to understand what, why, and where, and in what scenario you want to use them. So we'll start with rsync. I think that's probably the granddaddy of file-based backups at this point. A lot of people have been doing that for many years. It's pretty well understood, but basically it's a syncing of file by file to a remote location, often done over SSH. That's usually the transport vehicle as well. Updated files are replaced, removed files can be deleted, but you have options to tweak those. You can do kind of one-way pushes. You can not delete files. Like there's a gazillion little knobs to kind of tweak it to fit the behavior you want for your backup scenario. And there's push and pull tasks and all that good stuff. But one thing I would point out, Chris, about rsync is a lot of people use that to back up to not TrueNAS as well.
Yeah, it's an open protocol. And again, it's one of those things that we like to say we're an open source product. We're open standards. We'll interact with it. If you want to rsync to something that's not a TrueNAS system, go right ahead. Of course, if you're not using something that supports ZFS, you may not have that really strong assurance that your data is going to stay fine on the other end. So, of course, we would always recommend you're going to rsync to somewhere, rsync to another TrueNAS machine.
That would be the safest thing to do, but we also understand reality is sometimes you only have a target and it's over SSH. As long as it's another POSIX compatible file system, rsync should work reasonably well. But related to rsync, I guess we should get into rclone. I think not as many people understand this one, but in many ways it's super similar to rsync. It's basically, if you look in the TrueNAS UI, they're almost very identical between the two. This is the cloud sync is what we label that in TrueNAS, and it's using rclone in the background. The biggest difference is this isn't syncing to another POSIX file system. This is syncing to S3. So that's really the difference in implementation here. But at the end of the day, it's very similar. There's some different advanced knobs you can get into for setting the number of simultaneous transfers, but either way, they both kind of act the same way on the host side where they're scanning files, looking for changes, and then, splatting it off to your remote side for your backup. So those two are very, very similar. But then the last one, which is probably newer, maybe folks don't understand as well yet, is Restic, which is actually the basis of true cloud backup inside of TrueNAS. So if you're running on Electric Eel, you're running any of the newer scales, you saw this new option for true cloud backup, which is similar to rclone in the sense that it's backing up to a cloud provider, in this case, our partner's storage. And it's a little different in respect to how it does its backup. It's not just taking files and dumping them off into the object store and just calling it a day. It's doing a lot more behind the scenes that you're maybe not aware of. It's basically putting the files into a repository. It's encrypting them by default. It's deduplicating them by default. It's compressing them by default. So you kind of, all these other features, which you can kind of do in the other protocols if you know what you're doing and you can tweak it just right, it just does out of box. And the other super cool thing is you can take snapshots of it on the cloud side. So one of the issues with rsync is if you're backing up to a POSIX file system somewhere, you don't know like if it's being snapped on the other side. What if the other side deletes a file? Using the TrueCloud backup, you get some more options to say, I want to also keep copies of this. So doing a backup won't blow away your only copy of the file you have on the remote side.
Yeah, you have the options for those versioned backups, which is a pretty fantastic thing to have. You can, again, it's some of that ZFS style snapshotting and being able to revert to older versions of it. But again, extend it up into those cloud providers like our partner Storj.
Yeah. That's an interesting way to think about it. It's that ZFS twist where it's like we kind of have expectations of, I want to be able to snap things. So TrueCloud Backup provides that. But a couple things to note, though, about file-based backups on TrueNAS, which, again, some folks are aware of. Not everyone's really thought this through, but backups are handled a little differently. Because they're file-based, there's certain things that maybe don't go along with the backup and don't transfer well. For example, NFS v4 ACLs may not fully be replicated and backed up. So you can consider these a full data backup, but maybe potentially lossy for metadata, something to be aware of.
So that's like your file ownership and permissions or something. So if you're doing a restore from one of these file-based things, you'll probably just want to double check that when you get your files back.
Yes. Absolutely. So your content's good, but you may have to set up permissions and all that good stuff again. And one thing also to point out is each of these solutions, the three I mentioned, they all have similar mechanisms in that they have to scan the file system to look for changed files. So now they do some tricks to try and speed that up. They look at, modification time. They look at, timestamps or they do checksumming. In the case of Restic, it only backs up, the blocks that have changed within a file. So it's not backing up the full file like, say, rsync would. So again, subtle differences between them, and you should probably take a look at the documentation if you're curious to kind of dig into that, because those have implications for like how much data you're sending over the wire every time, how much data is being backed up, how much load it's putting on your TrueNAS while it's doing the backup and going and scrubbing all this. So one thing again to be aware of is if you have a ton of files, you start getting into millions and millions of files to back up, there's a time cost to that. I have to go read all that data, check everything, make sure it's good so I know what to back up, right? Or if it's a lot of capacity again. So be aware, there's little nuances and caveats to those, and you just want to set up the right thing for your use case.
Absolutely.
But let's flip to the other side of the equation. We come from ZFS world. We have better goodies to play with too.
Exactly.
So
we got ZFS replication here. Yeah. And that one's fantastic in terms of like a speed and overhead or lack thereof kind of thing. Because with ZFS replication, you're working at that ZFS record level. You're sending over the underlying layer of the file system. You're sending ZFS. So because ZFS is copy on write by nature, we don't need to do any kind of complicated scanning of those existing files on top. It's going to know by design which records have been changed because you've got that copy on write behavior built in. This makes it way faster, way more efficient, but it does require that you build those snapshot chains. And we do this for you in our ZFS replication within TrueNAS. It means you have to make sure those snapshots exist and they're set up in order to leverage that behavior. So if you say, I'm going to snapshot my data set every 1 week, then you're going to want to do that replication kind of in a granularity of every 1 week as well. But all it needs to do is just say, I already know everything that's changed. I'm just going to package up this entire snapshot from a ZFS perspective, and I'm going to send all these records over. It's going to be checksummed for you automatically. It's going to be compressed for you already. It's just going to ship all of the records that it needs to do. If you're using deduplication on top of it, it's just going to send only the records that need to actually be changed at that underlying file system. So you still get to preserve all of the wonderful goodness in the space reduction, the efficiency, and the data integrity of ZFS, of course. The downsides of this is you can't do things like a two-way synchronization easily. You can't have both sides of a ZFS replication being simultaneously modified because you're always kind of syncing one over the other. So you have to do a choice for, which one of these is going to be my authoritative copy, and then I'm going to sync it over my destination. We have a lot of customers in TrueNAS Enterprise and even in our community base who are doing cross-replication, of course, with two different data sets. If you've got, a site A and a site B, or if you're in our home user, maybe you and a friend are doing this, you're cross-replicating your data sets to each other. So you say, hey, Chris, I'm going to replicate my, crucial backup over to you in an encrypted data set, and you can do the same over to me. And kind of in case of failure, we can just reverse the direction of that sync and say, hey, I had a fire. My house is gone. Okay, I've set up a new TrueNAS machine. I'd just like you to send that latest snapshot of my data all the way back over to me, and we'll just build it up from the ground up. So much more efficient that way, but it's much more difficult to do things like reach in and pick up multiple levels of a file or individual files at a time. You have to do things like promoting your snapshots up to effective file systems. There's a little bit more administrative overhead, but in terms of efficiency, I don't think you can beat it.
And one thing you touched on, but I think we should expand on a little bit too, is you mentioned encryption too. This is kind of a neat property. If you're doing the file-based backups, of course, they're reading the files unencrypted to then send over the wire, and you got to kind of trust that the remote receiver is going to either encrypt them or not encrypt them. Like, you got to trust the remote end. One of the nice things about ZFS's native encryption is when you pair that with replication is you don't have to send the keys. You can send the entire replicated data stream. So the other end is receiving this data, but it stays in the encrypted format and they don't necessarily have access to it. So I don't need to see your data, Chris. You don't need to see mine. Yes, we're sharing. We're helping back each other's data up, but until I provide my key, it can't be unlocked on the remote side. So that's an interesting property of it as well.
Exactly. You can do this with a file-based replication as well, but it means you have to read the data from your encrypted disk. You have to encrypt it manually again before you send it, maybe with a different key, and then you send that encrypted copy over. So it's a lot easier to be able to just say, we're going to use that same already encrypted data. We're going to shoot that over. But the crucial thing is, of course, whenever you're dealing with encryption, back up your keys.
Absolutely.
Absolutely. That's one thing. I mean, ZFS is great at protecting your data. If you lose your key, it's going to protect the data from you as well, unfortunately. So make sure, keep
By design. That's not a bug. That's a feature.
Yeah, that is a feature. Keep those keys backed up. Print them off in hard copies, lock them in a bank vault or something like that if you have to, but don't lose those keys.
So one special mention I'll just toss in here as a freebie, Chris, is we have some tools like SyncThing in the App Store as well. Some people use things like that for backup also. SyncThing, again, think of it kind of as rsync, but on steroids. It's a little more dynamic in that when a file is changed, it can get the notification and back it up immediately as opposed to on a schedule. So that's kind of cool. Some people use those tools as well. The nice thing about SyncThing is you can do, bidirectional or even multi-site replication. So it's keeping a bucket or a data set in sync in multiple locations, multiple geos all at once. Of course, now you have some caveats with conflict detection. If two people modify a file at the same time on two different sites, it has to create two copies of that file, and then you have to pick which one you're going to keep, right?
Yeah.
Merge the changes in manually. But again, special mention, that's another way some people accomplish a lot of the same thing.
Yeah, I use that one myself, even for when I'm traveling. I have a SyncThing instance on my desktop, my laptop, and my TrueNAS machine itself. So I say, hey, if I have a file that I want to be, locally available when I'm offline, if I'm in a plane or something, I can edit it on my laptop. As soon as I touch down, I'll open up the laptop, let SyncThing do its thing, and I know it's back home safely.
Yeah, that is one cool feature that I've done on TrueNAS as well, is I have the SyncThing on TrueNAS, then on my laptop and a desktop. So TrueNAS is always on, right? I never power that off. So as long as that's available, if I'm editing files on my desktop or laptop, they'll just sync up. Those come and go, right? I don't leave those powered on 24/7, but very handy when you have like a working directory and you just want to make sure no matter which, system you sit down in front of, you can get the latest files, because TrueNAS will always have the latest copy that was synced to it.
Absolutely. Alrighty.
All right,
hey,
well,
we got some viewer questions. Yeah, we got some good ones here. So I'll read out the first one. I think this is probably up your alley to answer, Chris.
Yep.
So here's a question from Paul, who wrote it in. He says, great podcast. Maybe the following couple questions could feed into a future episode. I think we're going to be able to answer the first one here, Paul, but we might have to take some of those later ones, and we'll punt on that and probably answer them in a follow-up episode. So here we go. Chris, he says, a few episodes ago, you talked about why you switched from FreeBSD to a Linux base. I get that. My firm has been hosting on FreeBSD for a decade, and we're moving to Linux for a bunch of business and not necessarily technical reasons. In our examination of the various flavors of Linux, many don't feel like a true enterprise tier solution. He comes from a Sun Solaris background, starting in computer stuff in 1994 after spending some time doing broadcast and sound engineering. But he also worked with AIX, HPUX, IRIX. And he says the EL family, so Red Hat, Alma, Rocky, Oracle, says all feel more stable and enterprise in their attitude compared to Debian or Ubuntu. So he asks, what were the reasons we selected Debian and Ubuntu instead of one of the enterprise Linux branches as the basis for TrueNAS?
Okay, well, first of all, IRIX, I haven't heard that name in a long time. And yes, I'm old enough to have actually touched an IRIX system a couple times in my career.
I don't mess AIX, little AIX in my history. Not
AIX, much, I've done HPUX, a lot of SCO Unix, all that. Yeah, so I'm glad that's all behind us. But that said, it's actually an interesting question, and it's a good question because we did have to look into this when we first started kind of kicking the tires internally on, hey, we're going to do this Linux thing, which distro makes the most sense. And of course, there's a lot to choose from. We did early testing, I think, on Fedora with performance. We, of course, played with Debian. And at the end of the day, the reason we opted to build TrueNAS on top of Debian was a couple things. First of all, it's a very stable, well-known open repo, not necessarily controlled by a corporation. That kind of rules out a few different options. We also liked its connection with Ubuntu because at the time, and still today, Ubuntu is one of the few other entities which is pretty pro ZFS. They were working on things to make ZFS work in Ubuntu. And we were like, that's great. We can piggyback off some of that. There can be maybe some potential collaboration there. It was good to see that. We didn't see that so much in the other distros. And honestly, at the end of the day, it didn't really matter that much. If I'm honest about it, we build TrueNAS to our specifications to do what we want. We build our own kernel. We're not taking stock Debian kernel. Yeah, we take a handful of Debian packages, and those are build components. But a lot of those, if you take a look at our build script, repos and how we kind of assemble TrueNAS, which is all on the GitHub site, a lot of that we're overriding and building ourselves. We build ZFS ourselves. We build the kernel ourselves. We build probably several dozen packages at this point, custom built for a TrueNAS image. So yes, at the end of the day, if you go dig into the shell, which some people do, you'll see apt and friends there. And yes, it's Debian. But again, it doesn't really play as big a role as you would think it would. We could have probably just as easily built it off of an alternative, distro. Pick your choice. Arch could have been one we looked at, for example. But at the end of the day, we were pretty comfortable with Debian. We liked the size of the community. It seemed very stable and healthy, and we've been pretty pleased with it. No solution's perfect. They all have things you wish were different, or you struggle with little bits here and there. But again, none of them would have been perfect for that, and we would have had to kind of invent some of our own things to make sure TrueNAS is what it is now. Okay. Hopefully that answered your question, Paul. I appreciate it. That is an interesting history question, but it was very easy to get spun up as well on Debian. That, I say, they make it easy. They had some really good build scripts and stuff set up in the early days. It was fun.
Yeah. And again, Paul, we saw the rest of your question, quite a few of them. It was a real multi-parter. So we'll have to sort of dissect that one, and we will come back to answer those probably in a later episode. But we wanted to jump into a question we didn't get to last time, coming from Jason here. And he's asking questions about special VDEVs. He says, I'm writing this request as a result of Chris's ask to do so in the forum when we were discussing the special VDEV resource that was written by one of our forum members. Summarizing, he says, please do not jump right into small file allocation out of the gate. Well, we will talk about it, but I promise I will stay away from that at the beginning. He says, as one of the target demographics for this feature, the confusion lies strictly around determining how much space we will need for metadata storage on special VDEVs. And one of the purposes, the key purpose of the special VDEV is storing that ZFS metadata. This is, your directories, the equivalent of modified times, checksums. Putting those on solid state drives does make things like a directory listing and general queries like that much, much faster. So back to the question, he says, I understand we could do a query on existing data, but of course the problem lies in that chicken and egg conundrum. When we're building our systems and trying to plan for metadata, where maybe we know the type of data we're going to store, we know the approximate size we're going to store, but there's a lot of confusion over the anticipated size of metadata associated with the type of data that we see. Most people know what they're going to store on the pool, but the problem lies in this sort of idea of how much percentage you need for a standard workload. He says, what's a standard workload? Some of us are archiving large files, videos, video editing, I believe, is what he's looking at here. But he says, can we work out a couple rules of thumb, idea for, small document files or this percentage, large video files, you need this percentage. Real world results will, of course, vary, but we can work out where to start. And it gives them a personal place to determine how much they're willing to spend to give some wiggle room without sacrificing redundancy. And of course, redundancy is something that is incredibly important with special VDEVs. A special VDEV is considered the same level of critical to your pool's health as the regular ones. So if you have a nice 6-wide RAID Z2, for example, but you put only a single drive for your metadata, well, what you've done is you've made your entire pool reliant on that single metadata drive continuing to exist. Yeah, don't do that. Use at least a mirror. And ideally, you'd want to give the same level of redundancy to your metadata that you would to your primary data. So if you do, if you've got a RAID Z2, especially if multiple VDEVs of them, you might want to consider actually 3-way mirrors for your special metadata. But
yeah, you got to remember, without that, you're toast. You lose the pool. That metadata is the copy.
That is. I mean, it's kind of like if you remember back in the old days of library cards where you would look them up with again, I'm dating myself here, the old Dewey Decimal System with all of those categorical numbers that said, oh, this is where the book is in the library. Trying to do that would be like trying to find something in an enormous library if you didn't have your metadata. if somebody had kind of set fire to that whole stack of library cards. The data might be there, but good luck finding it. So let's jump into this one a little bit, Chris. I mean, it's tough for us to do generalizations on things, but I think we can make an attempt here. Again, there is a command that you can run against the existing data. It's a ZDB command, and I'll put it up on the screen. I'll put it down in the links. We'll talk about it more. That will give you some very detailed space reporting on what type of ZFS objects. So, I mean, the level 0 is your data blocks. That's what lives on your spinning disks or your main data VDEVs. But there's other levels of metadata. You've got, just going through the list here, you got, your master nodes, your ACLs, your data set properties, space maps, your allocations of space maps, your intent logs, dnode trees, all kinds of technical stuff we could go into. But trying to boil it down into those sort of rules of thumb can be difficult.
Yeah, it's tricky. There's just too many nuances usually, but we should try and give at least some starting place guidance, I think, on how to do this.
A starting place to do it, I think, was like 0.1%. So in the idea of like one gigabyte of metadata, probably per 1 terabyte of physical data. And this, in no small coincidence, aligns with one of those old rules of thumb about how much RAM do you need for your TrueNAS system. And people would say, oh, you need 1 gig per terabyte. That was primarily derived from the idea that even if your data wasn't necessarily cached in RAM, you really, really wanted that metadata to live there. And that's about where you're at. So it is about that, 1 gig per terabyte kind of sizing. Again, if you have lots and lots of very tiny files, Yeah. Here comes the asterisk. Here comes the weasel words, right? I'm in marketing. That's what we do, of course. So if you're using those really big files, if you're storing video files, you will probably end up using less space, because if you have a record size on your data set that says 1 meg, well, you only need a couple of bytes and you're indexing 1 megabyte of data. So you're under that, the 1K to 1 meg ratio there. But if you're using lots of ZVols for iSCSI, well, you might be using a couple bytes to index a 8K or 16K record. Much like we talked about in a previous episode with L2ARC, for example. We said the smaller your record size, the more data or more RAM you're going to need to hold all that metadata. So I would probably consider that 0.1% is a pretty healthy number that would cover the vast majority of use cases. The question about expandability, redundancy, because one of the key limitations on a metadata VDEV is you can only create them as stripes or mirrors. We've already established don't use a stripe for your metadata. So you'll want to create multiple mirror sets if you need to grow them. So you could certainly say, I'm going to start with creating a 2-way mirror or a 3-way mirror, because you can change the width of those individual mirror VDEVs. You can say, if I started with a 2-way, I can grow it to a 3-way later. But you can also add an additional 2 or 3-way VDEV on top of that to your metadata group to say, that's how I'm going to grow. Now, as far as removing them, of course, the main asterisk is as soon as you have a RAID Z data VDEV, your ability to remove VDEVs, including those special ones, is gone. So if this is something you're considering experimenting with, ask yourself, do I have a RAID Z data VDEV first? If you do, your experimentation is strictly one way. Once you have added that metadata or that special VDEV, you can't remove it again. So be prepared to give it that level of redundancy that it needs.
Absolutely. I know he told us not to ask or talk about small file allocation out of the gate either, but that's
exactly
where, again, all the asterisks will start coming in.
Yeah, the horse has left the barn. We're out of the gate now. We can talk about it.
Absolutely. And then you can go and throw dedupe blocks in as well, because that's another thing you can do on the special VDEV. So it can get tricky. It's just, again, if this is going to be something you want to leverage, maybe do a little bit more research, read on it, understand your use case, and build a healthy safety margin. And when you're sizing that.
Exactly. And certainly, we said we wouldn't talk about it out of the gate, but small files is something that, maybe we need to shed a little bit of light on. It's, again, related to the record size. So if you say, hey, I want to set my small files limitation up to 128K, well, you definitely want your data set's record size to be larger than that. Otherwise, everything that lands on there will get chopped up by ZFS into those 128K records, which will then all qualify to be included on your special VDEVs. So you'll just fill them up really quickly and, probably won't store what you want to on there.
Yeah.
So in this case where somebody's editing video files and they say, I'm going to set a dataset record size of 1 meg. All of the 1 meg chunks for your main video files, they'll land on your spinning disk storage for that bulk capacity. But maybe you've got tiny little bits of metadata that go along with them, little sidecar files. That's where you're going to need to set that special small files property to something that's big enough to capture those little tiny sidecar files, but not so big that you're going to grab the actual data blocks for your video.
Which is one of the points of having the special VDEV anyway, because there's some real world use case. Those sidecars could be the thumbnails, or it could be, different important bits of net metadata that you want to be able to scrub through quickly. XML,
And the crucial thing is, again, we're saying metadata here, but it's important to make the distinction between what ZFS considers metadata and what your client application considers metadata. Those little XML sidecar files we're talking about when you're doing your photo or your video editing, ZFS on its own says those aren't metadata. That's just a normal file to me. Mm-hmm. You have to use that special small blocks property to tell it to store those files somewhere else in order to benefit from that acceleration. So hopefully, Paul, I'm sorry, that was Jason. Hopefully, Jason, that's an acceptable answer for you here. And hopefully we didn't spend too much time talking about small files. Again, I'll probably be jumping into the forums to discuss this further because, like we both said, it's nuanced, it's complicated. There's a lot of screws you can turn on this one, but it's worthwhile to invest because he did call out that there's probably real world benefits for performance for a lot of users. It's just really important to understand the caveats, especially around that need for redundancy.
Absolutely, except in my case because I went all flash now and I just got tired of fooling with it.
Wow. Okay. I mean,
that's me though.
If you can club the problem with NAND, then absolutely.
That's one way to solve it.
The easy answer is just throw everything on all flash. Everybody buy yourself a pallet of NVMEs or somewhere.
Right, sure.
Exactly. I hear we got a nice 24 bay system that can handle a whole pile of NVMe. Everybody, just go buy an F series, right?
Yep. Yeah. Go nuts, folks. That's one way to solve the problem.
Yeah. I'd love to have one of those in my basement. Hint, hint.
Yep.
Yeah, come on, make it happen.
We already messed Christmas. Sorry.
Oh man,
maybe next year.
It was just my birthday too. All right.
Oh, bummer.
Yeah. Well, hey, thanks everybody for tuning into the T3 podcast. Please continue submitting those great technical questions over to us at t3@truenas.com. Again, feel free to drop us messages in the comment section. We see them all. We try to respond whenever we can. Don't forget to like the video, subscribe so you don't miss our next episode, and we'll see you next time.